Okay, so now that we have the formula for the trapezoid rule, let's try to apply it to an example. Okay, so we want to approximate the integral from 0 to 1 of sine of pi times x dx using the trapezoid rule using 6 subintervals. So first let's sketch the graph to get an idea of what this will look like. So we're integrating from 0 to 1. So sine pi x in this interval will look like this. And then we want 6 subintervals. So let's mark off the endpoints. Right, so halfway would be 1/2. And then because there are 6 of them, this would be 1/6. This would be 2/3. This would be 1/3. 2/6 or 1/3. This would be 2/3. And this would be 5/6. And again, we approximate these slivers using trapezoids connecting the endpoints. And so we see that these trapezoids give a better fit to the curvature than the rectangles that we did for the midpoint rule. So this in general will give a better approximation. Okay, so then the width, delta x, so in general delta x is b minus a over n. So b is 1, a is 0, there are 6 subintervals, so delta x is equal to 1/6. Okay, so let's calculate this using trapezoidal rule. So let's remember how the trapezoidal rule goes. So we have to calculate the function value for each of the endpoints. The first and the last one have a coefficient of 1/2, and all the middle ones have a coefficient of 1. Right, so I have to take 1/2, the function value at the first endpoint, and then x1, x2. So this is x0, x1, x2, x3, x4, x5, and x6. So I compute the function values at those points, so I can get the end to the trapezoid, and then the first and the last one have a coefficient of 1/2. So x1, and plus f of x2 plus f of x3 plus f of x4 plus f of x5, and then x6 would be the right endpoint, so that gets a coefficient of 1/2. And then the whole thing is multiplied by delta x. And so again, if we look back at the trapezoidal rule formula, the left endpoint x0 and x1 have a coefficient of 1/2, and all the middle ones have a coefficient of 1. Okay, so now let's start plugging things in, right? So I plug in these x values into the function. So f of x is sine pi x. So x0 is 0. Plugging into here, you get sine of 0. x1 is 1/6, so you get sine of pi over 6. x2 is 1/3, so plugging into the function you get pi over 3. x3 is 1/2, plugging into the function you get sine of pi over 2. x4 is 2/3, plugging into the function you get sine 2 pi over 3. And then x5 is 5/6, so you get sine of 5 pi over 6. And finally x6 is 1, so plugging it in you get sine of pi. Then delta x is 1/6. Okay, so now let's calculate these function values. Sine of 0 is 0. So you get 0 over 2. Sine of pi over 6 is 1/2. Sine of pi over 3 is square root of 3 over 2. Sine of pi over 2 is 1. Sine of 2 pi over 3 is square root of 3 over 2. Sine of 5 pi over 6 is 1/2. Sine of pi is 0. And then the whole thing is multiplied by 1/6. Okay, so now let's add this up. So you see that if you add what's in here together, you get 2 plus square root of 3. Right, so 1/2 plus 1 plus 1/2 is 2. And then square root of 3 over 2 plus square root of 3 over 2 gives you square root of 3. Then that thing times 1/6. And if you plug this into a calculator, see that this is approximately 0.622. So this is what the trapezoid rule gets you, with 6 subintervals. So let's compare it to the actual value again to see how this compares to the actual value. So I'm going to integrate from 0 to 1, sine pi x dx. The antiderivative is minus cosine. And because there's a pi in there, you have to divide by pi for the antiderivative. And you evaluate it from 0 to 1. So plugging it in, you get minus cosine pi over pi plus cosine 0 over pi. This is minus 1, but minus minus 1 becomes a plus 1. So it's 1 over pi plus 1 over pi, which is 2 over pi. And then if you plug it into a calculator, this is approximately 0.637. So we see that the approximation is fairly good. So if we want to calculate the error again, so you take the difference between the two. See that the error is 0.015. So it's 1.5 hundredths off from the actual value, so which is a good approximation. And then the relative error. So you divide the absolute error by the actual value. You'll see that this is approximately 0.024, whereas a percentage, it's 2.4%. And so it's only 2% off of the actual value. And so we see again that the trapezoidal rule is only 2% off the actual area here.